Greetings, everyone. My name is Andreas Mkhethe. Today we'll be focusing on integration. Well, integration is a continuous analog of sum which is used to calculate areas, volumes, and their generalization. And integration in our real world is used to determine the shapes of the constructions, building constructions, or the length power cable in engineering. Integration and differentiation are connected as inverse operational in calculus. So in differentiation, we break down, then in integration, you accumulate all those changes. Well, at the end of this lesson, I expect learners to be able to integrate by part and also be able to integrate using use substitution, because we'll be having problems in use substitution and also integration by part. So let's begin with integration by part. For integration by part, the formula, the formula for integration by part says, the formula for integration by part says the integral of u dv, u dv is equals to u v minus the integral of v du. So according to the formula, that means we are going to have u and v, dv and du. This is the general formula for integration by part. So our first question says, our first problem that we must integrate says the integral of e to the x sine 3x. So here we are given a question, we're given a problem saying we must integrate e to the x sine of 3x. Remember, integration by part is consist of two functions. We have the first function and the second function. So for you to know which one is the first function, which one represent u and which one represent dv, that means we must use the method called ILATE method. Well, the ILATE method, when we use this ILATE method is used for us when we choose the u. So we use the ILATE method to choose the functions for u. The I stand for inverse trigonometry, L stands for logs, A stands for algebraic functions, T stands for trigonometry, then E stands for exponential. You choose them according to this ILATE method. If T comes before E, that means your U is going to be trigonometry. So in this case, we are given exponential and also trig functions. That means our U in this case is trigonometry, since trigonometry comes before the exponential in the ILATE method. So let U be equals to let u be equals to sine 3x. Therefore, dv is equals to e to the x. Now since we have our u and also our dv, that means we must have our du and also our v. So our du is going to be 3 cos 3x. Then our v, you integrate dv, you will get e to the x. E to the x. Now that we have everything that we must have in our formula, that means we can simply substitute. Let's just stop this. We can simply substitute everything into the formula. The formula says the integral of u dv is equals to u v minus the integral of v du. So we are going to say the integral of e to the x sine 3x is equals to, our u is sine 3x sine 3x, then our v is e to the x minus the integral of v. V is e to the x, then du is times 3 times 3 times 3 cos 3x. Now, since we are here, you can tell that the integral of e to the x and 3 cos of 3x is also integration by parts. So we still continue to be integrating this part over here. So we are going to be integrating this part over here. But before, we must take out the constant first. So we will have sine 3x e to the x minus 3, the integral e to the x cos 3x. Okay, let me just put this over here. Now the integral of e to the x cos 3x we are still going to identify our u and also our dv. U is equals to, remember in this case, our u is our trigonometric function because of 3x, then v dv is going to be e to the x. So du is equals to, remember when you differentiate cos, you get negative 3 sine 3x. Then v is going to be e to the x. Now let's substitute this into the formula that says e. That says u dv is equals to uv minus the integral of v du. So our u is cos of 3x cos 3x times v is e to the x minus the integral of e to the x into minus 3 sine 3x. Then we simply Simplify, have cos of 3x e to the x minus. Now, while we are simplifying, we can simply take out the constant. Our constant is here is -3. So we have plus 3, the integral of e to the x sine 3x. So from this case, remember this part, we were just doing it because we were differentiating this part. We were integrating this part. So we are going to substitute it now. We will have, let me just do this. We had sine 3x to the e minus so our integral says e to the x sine 3x is equals to sine 3x sine 3x e to the x. Just increase this a little bit. Then minus 3. Now, this one we've already integrated, and when we integrate this thing, this one, we got this one. So we're going to substitute this one where we see integral of e to the x cos of 3x. Open the bracket, cos of 3x e to the x plus 3, the integral of e to the x sine 3x. Then from here, we can simply multiply over everything. We are going to have sine 3x sine 3x e to the x minus 3 cos 3x cos 3x e to the x minus negative times positive is minus 9, the integral of e to the x sine 3x. Now, if you check correctly here, from this case, this integral of e to the x sine 3x is the same as the integral of e to the x sine 3x. And the integral of e to the x and 3x is what we are trying to integrate those. So we can simply let let me just close. Let the integral of e to the x sine 3x sine 3x be equals to I. Therefore, I is equals to sine 3x e to the x minus 3 cos 3x minus 3 cos 3x e to the x minus 9. Now, remember we said the integral of e to the x sine 3x is equals to I. So we have minus 9i. From here, then we simply simplify. We'll take this I plus 9 to the I is equals to sine 3x e to the x minus 3 cos 3x e to the x. Then I plus 9i, it will give us 10i is equals to sine 3x e to the x minus 3 cos 3x e to the x. Then we simply divide both sides by 10 since we are looking for I. Then I is equals to sine 3x e to the x minus 3 cos 3x e to the x. And from here, remember, divided by 10. Remember, from here, we said our I represent the integral. Therefore, I is equals to the integral of e to the x sine 3x That means so we see I will substitute e to the x sine 3x. So we have the integral of e to the x sine 3x is equals to sine 3x e to the x minus 3 cos 3x e to the x all divided by 10. So this is our final answer for the integral of e to the x sine of 3x. Now let's look at another problem. So our second problem, we have the integral our second problem we have the integral of x cos 3x simply do this. The integral of x cos of 3x. Let me write it properly. Increase the thickness, then the integral of x sine sine, no, I think it's cos 3x. No, I just think it's properly just do this. Our problem is the integral of x cos 3x. Also, in this case, we must identify our u and also our dv. So in this case, we have x cos of 3x. That means here our u is going to be x, then our du is going to be our dv is going to be cos of 3x. So let u be equals to x. Then you know when you differentiate x, that means our du is equals to 1. Then dv is equals to cos 3x cos 3x, then v is equals to sine. When you integrate cos of 3x, you get sine 3x sine 3x divided by the inside function of which, divided by the differentiation of the inside function of which is 3. And from here, you can simply substitute everything into the formula. Now, to recall the formula says u dv is equals to u v minus integral of v du. Now our u is equals to x, then our v is equals to sine 3x pencil is not working nicely. Sine 3x divided by 3 minus the integral of v, and v is sine sine 3x divided by 3 times du. Our du is 1. And from here, we simply substitute. We simply simplify. We will have x sine 3 sine 3x divided by 3 minus, then from here we can simply take out the constant to make things easier for us. The constant is 1 over 3. The integral of sine 3x. Now, since we are here, we can simply find the integral of sine 3x to make the things easier for us. We'll have x sine 3x divided by 3 minus 1 over 3. Then when you integrate sine 3x, you will get minus cos 3x. Is it positive or negative? Yeah, it's negative. Divided by 3 then we simplify. And when we simplify, we will have x sine 3x divided by 3 minus 1 over 9. Now, negative times negative is going to give us positive. So we'll have positive 1 over 9 cos 3x plus c. Now, this is the final answer. This is the final answer. Let's do this. This is the final answer for this integration. This is the final answer for this integration. This is the final answer for the integral of x cos 3x. Okay, let's have another integration by part. Then we'll be diving into integration using U substitution. Okay, now let's do integration. We'll be doing a few questions on integration using U substitution. Well, let's say you are given pi ln x all over x. So for here, you must be able to identify which one will be your u. So let u be equals to L n x. That means du will be equals to 1 over L du by dx, 1 over x. Just scrap this and write it nicely. 1 over x. Therefore, dx is equals to x du. Then we say the integral of pi. Remember, we said ln x, let it be u, so it will be to the exponent du all over x. Then x, and we have our x du. Not the x, I need to write du. From here, this x will cancel this x. Therefore, we'll be remaining with the integral of pi to the u. So when you integrate this thing, you will have put this over here at the top. You have the integral of pi to the u is equals to pi to the u divided by ln x, ln x plus c, of which is equals to pi. Now we know that the u is equals to ln x, so you'll have u as ln x divided by ln x plus c. So this will be our final answer for this integration using u substitution. Now let's look at another problem on u substitution. This one is a trig function one. We have we have the integral of cosec squared x divided by 1 minus cot x squared. So in this case, our u is going to be, let u be equals to 1 minus cot x. So when you differentiate 1 minus cot x, you will get cosec squared. You will get du is equals to cosec squared x dx. Now remember, we want our dx. That means we will divide both sides by dx. We'll have dx. We'll divide both sides by cosec squared x, I mean to say. We'll have dx is equals to du divided by cosec squared x. Now, since we have our dx, we can simply substitute everything. Where is it? There it is. So let me just put this on the side here. Let's divide this into 2. We will have the integral. We'll have the integral of cosec squared cosec squared x divided. Remember, we said 1 minus cot x is equals to u, so we'll have u squared. We'll have u squared times du all over cosec squared x. From here, this cosec squared x will cancel this one, so we'll be remaining with the integral of du all over u squared, of which is equals to 1 over u squared. du. And when we integrate this, when we integrate 1 over u squared du, you will get okay, let's simplify it first. When you simplify it first, we'll have the integral of u to the negative 2. So here, when you simplify this, we will have u to the negative 2 plus 1 plus 1 all over negative 2 all over negative 2 plus 1, of which is equals to 1 over, of which is equals to negative 1 over u plus c. Now we know the value of u. The value of u is equal to 1 minus cot x. That means our answer is going to be minus 1 all over 1 minus cot x plus c. So therefore, this will be our final answer. This will be our final answer. This will be our final answer. Now let's look at another problem on your substitution. Another problem, we are given the integral. It's here. We are given the integral. We are given the integral in the integral of cosec cosec 2x minus 1 times cot 2x minus 1. So in this case here, remember our u must be the inside function of the trig function. So our u is going to be, let, this pencil is giving me problems, bear with me. Let the, try this one. Let u be equals to 2x minus 1. Therefore, our du is going to be 2x. Du is equals to 2 dx. Now, our dx is equals to be dx. Is giving me problems. Dx is equals to du. du all over 2. Now let's substitute everything in the original equation. Our equation said the integral of cosec remember our function, our z function is now u quad u. Then times du all over 2. So we can simply take out the constant, of which is 1 over 2. We'll have 1 over 2. Then the integral the integral of cosec u cot u. U. Now remember, cosec u cot u, they give you, so we'll have 1 over 2 the integral of cosec 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 u not supposed to be the integral, going to be 1 over 2 cosec u plus c. Now we know the value of u, 1 over 2. We put this in here. 1 over 2 cos sec. Our u is 2x minus 1 plus c. So this is the final answer for that integral. So today we did integration by part and also integration using u substitution. So let me just give you something to do. Then if you have a problem, I'll find it in the comment. I'll give you the corrections there later. I'm going to give you one problem on integration by part and one problem on integration using u substitution. So go check, go try to attempt this one. The integral of e. This pencil is giving me problems. e e power 2x 2x sine x sine this one is for integration by part. Then using new substitution, we'll try this one. Using new substitution, go try using new substitution, go try this one. The integral of e to the integral of e to the power 1 over x divided by x to the power 3. Well, that is for today. Thank you for watching. Find you in the comments.